This is the module 20 through 21 review for your exam. On number 1, we start off with a water bottle that is shaped like a cylinder and is 22 centimeters high, 5 centimeters in diameter. The formula for the volume of a cylinder is pi r squared times height, but we're only going to take half of this formula, which is why I'm dividing by 2 here, because the problem said that it's exactly half filled with water, and we only want the volume of the water. So after substituting in all the numbers, the only thing I'd have to tell you is that be careful with this, because it is 5 centimeters squared, which means it would be 5 times 5, and that would turn into a 25. So after multiplying everything, we find out that we have a volume of 863.5 centimeters cubed for half of this cylinder. Problem number 2 is a triangular prism, which means that both bases are triangles, and they actually gave us the area for one of the bases, so that means I don't have to use my formula for the area of a triangle. I just need to use the formula volume equals whatever the base area is times the height. So the base area is 24 centimeters squared and the height is 9 centimeters, which would make it 24 times 9, which is 216. And the centimeters cubed comes from centimeters squared, and centimeters together would become centimeters cubed. Number 3, they're asking us to find the volume of an oblique prism, which the formula would be the same for a regular prism. So it would be volume equals length times width times height. The length is 9, the width is 5, and the height is 9. So after multiplying all those numbers together, we find out that the volume would be 405 centimeters cubed. On number 4, we have a sphere, which I drew here for you. And the formula for the volume of a sphere would be 4 times pi times r to the third power divided by 3. And they gave us the volume of the sphere, which means that I'm going to be taking this number and substituting it in for V in the formula for volume. That's exactly what I did here. I kept the formula for the volume exactly the same, but I substituted the 32 pi over 3. After doing that, I find out that whatever's on opposite sides that's exactly the same would cancel. So pi and pi would cancel. The dividing by 3 would also cancel on both sides, leaving me with 32 equals 4 times r cubed. If I divide both sides by 4, I end up with 8 equals r cubed. 8 actually turns into 2 times 2 times 2, because 8 is a cubed number. 2 cubed turns into 8. And r to the cubed becomes r times r times r. If I take the cube root of both sides in order to get r by itself, I end up with r on one side alone. And on the other side, I have 3 2's, so I end up with 1 2 on the other side. If I switch that around, I end up with the radius equal to 2, which is exactly what they wanted to know. They wanted to know the radius of the sphere. So we know now that the radius is 2. Number 5, they're asking us to find the volume of this composite figure. A composite figure, we obviously know that it's a few figures put together. So here we have a prism and we have a cylinder. So the rectangular prism's volume would be length times width times height. And I'm going to add that to the volume of the cylinder, which would be pi r squared times height. So I know that the volume of the rectangular prism is 8 times 5 times 4. Centimeters, centimeters, centimeters. That would become centimeters cubed. For the cylinder, it would be pi, which is 3.14. The radius is 1 centimeter squared, which would turn into 2 centimeters, centimeter squared, centimeter squared. And the height, which is 4 centimeters here. So basically, I'm adding centimeters cubed with centimeters cubed, which would turn out to be 172.56 centimeters cubed. On number 6, they're asking us about a right cone. So I drew myself a right cone here. And I know that it has a diameter of 12 centimeters and a height of 18 centimeters. The diameter, I'm going to need to cut in half because I need the radius for my formula. So the formula is pi r squared times height divided by 3. And there is no diameter in this formula. I need the radius. So the radius would be 12 divided by 2, which would be 6. And that's exactly what I put into the formula. Now be careful, because this 6 becomes 6 squared, which is 36, times 3.14 times 18, and everything divided by 3. So that would turn out to be 678.2 centimeters cubed. On number 7 and number 8, we're using this composite figure here, which is a pyramid and a rectangular prism. They told us that the rectangular prism at the bottom is a square here. So that means that this length is 10 and so is this length 10, even though it's not marked. So first of all, they want us to find the height of the pyramid. So I have the height of the entire composite figure, which is 18 centimeters. And I also know the height of the prism at the bottom, which is 7 centimeters. But what they're really asking us is the height of this pyramid here, from here to until I get to the prism. So if I take the 18 and I subtract it from the 7, I end up with 11 centimeters. And that's the height of my pyramid. I'm going to obviously need that height when I use it in the formula for the pyramid here, where the height is at 11 centimeters. I'm also going to need the height of the prism, which is 7 centimeters, and those are not the same. Okay, so now for finding the volume of the solid, I'm going to add my volume for my pyramid, which is length times width times height divided by 3. And I'm also going to need the formula for the volume of a prism, a rectangular prism, which is length times width times height. So the length of the pyramid is 10 by 10, 10 by 10, and the height of the pyramid, add that to the volume of the prism at the bottom. So 10 centimeters by 10 centimeters, because it is a square, and then the height of the prism, which is 7 centimeters. Multiply all that together. Once you're done adding everything, you should end up with 1067 centimeters cubed, since we are talking about volume. That completes page 1 of your review. So problem number 9, page 2, begins with a sphere with a radius of 5 centimeters. The formula for the volume is 4 times pi r cubed divided by 3. So all we need to do is substitute the 5 centimeters into our formula, and be careful with that because it is cubed. So that would be 5 times 5 times 5, and then times 3.14, and then times 4, and at the very end divide by 3. That should end up with the closest whole number at 523 centimeters cubed. Problem number 10 deals with an oblique cylinder. So which has basically for volume the same formula as a cylinder that's standing straight up. So the cylinder here is oblique, but it has a height of 3 centimeters. So the formula for the volume of a cylinder is pi r squared times height. So, and the other thing that you need to know is that they gave us the volume, so I can substitute this 3 pi in for v here, which is what I did here in red. Now, once I look at the formula, once I've substituted everything in, I find out that the 3's and the 3's cancel because they're the same on both sides. The centimeters and the centimeters also cancel, and the pi also cancel. So anytime you have something on both sides that matches, you can cancel it. Now, since I divided 3 by 3, I end up with 1, and on this side I ended up with r squared. Now 1 is the same as 1 times 1, and r squared becomes r times r. If I square root both sides, we find out that every time I have double for a square root, only one number can come out, so the 1 comes out and the r comes out. So that means my radius is 1. On problem number 11, we have a tangent and a secant, and they want us to find the value of x. So with the tangent, you're going to need to multiply the tangent times itself, so 6 times 6, so AB times AB, equals the outside, which is BC, times the whole thing, which is BC plus CD, so BC plus CD, and BC is 3, and CD is x. So once I distribute, I end up with 36 equals 9 plus 3x. If I subtract the 9, I end up with 27 equals 3x, and that means I have 3x equals 27, which is the same thing as x equals 9, and that is what they asked us to find on problem number 11, x. Here the directions for number 12 are up above. The problem is up above. So the directions for number 12 were for you to find the value of x, which is here. Okay, first of all, we start off with a tangent and a radius, which tells us that we have a right angle. That means our triangle here is a right triangle, and I can rewrite it off to the side. The radius is 12. I also know that this radius, since it is a radius also, is 12. Anytime I go from the center to the circle, they're actually the same length, center to circle. So that means these are congruent. So if this one was 12, so is this side 12. Now, I still have the x that I need to find. But what I'm going to do is I'm going to call this whole side y to make my problem easier. So I make this y. So that means this is the hypotenuse. So y squared. The Pythagorean theorem says that the hypotenuse squared is equal to the square of the sum of the other two sides. So 16 squared plus 12 squared, and that gives me 400. Y squared splits up into y times y, and 400 splits up into 20 times 20. Since I'm taking square roots on both sides, I have double, which is a y. That means I could take out the y. And I have double, which is a 20 on both, so I can take out the 20. Now I found my y. That means this whole length here is 20. But I don't want to know that whole length. I want to know this little piece. So if you can tell, all I need to do is take off the 12. So I'm going to take 20 and subtract 12, and that should give me my x. So that means x is 18. Number 13 is dealing with this right cone here. Now, if you notice, they gave you the slant height, which is 20, but they did not give you the height of the cone, which you're going to need if they're going to ask you for volume. They also give you the diameter, but you don't need the entire diameter. You need a radius, which half of 15 is 7.5. So if I recreate this triangle's measures over here to the side, I have a right triangle with the hypotenuse of 20 centimeters. I need to find the height, which is the x, and I found out that the bottom part of the triangle is 7.5, which is half of the diameter. What is the height of the cone? That's the first thing they're asking us for, is what is the height, the x here? Well, I'm going to use the Pythagorean theorem. So I'm going to use 20 squared here equals to x squared plus 7.5 squared. So I find out that 20 squared is 400, and if I take off 56.25, which is the 7.5 squared, I end up with x squared. Now that means that I need to square root both sides in order to solve my problem. So I end up finding that x is 18.5 centimeters. On part B of the problem, they're asking us to find the volume, which means I needed to find the height in order to do the volume. The formula for the volume of a cone is pi r squared times height divided by 3. There's the height again. But I found my height. My height is 18.5, so I'm going to substitute that in the height spot. The radius I actually know as well, because half of the diameter is the radius, which is what I found up here, 7.5, and it's in red again. And don't forget to square it. You got to multiply it times itself. So basically, if I multiply all these numbers and divide by 3, I end up with 1,089 centimeters cubed. If you notice, they asked you to find to the nearest cubic centimeter. That means you don't have any decimals. That was page 2 of your review. On problem number 14, page number 3 starts off with these problems that look like riddles, but they're not riddles. So if you see here, they're asking you for the circumference of the circle. That is the question. Find the circumference of the circle, which you know as circumference equals 2 pi r. Then they give you a clue. So the clue they gave you here is the area. The area is 25 pi. So we're writing down their clue. Area is equal to 25 pi centimeters squared. But we know the formula of the area of a circle, which is area is equal to pi r squared. What you want to do is you want to set these two equal to each other without the area involved. So 25 pi centimeters squared equals pi r squared. Whatever matches on both sides of the equation can cancel. So in this case, the pi's cancel. And I rewrote this as r squared equals 25 centimeters squared. If I square root both sides, then I end up with on this side an r, which equals the square root of 25, which is 5, and centimeters squared becomes centimeters. So now I have my radius. I can come back to the question, which was to find the circumference of the circle, and I now know my r, which will go here in this spot, the 5 centimeters. I'll substitute 3.14 for pi, and I'll leave the 2 alone. I'll multiply all these numbers together, and I find out that the circumference is 31.4 centimeters. That's what they were asking for. What is the circumference? On problem number 15, they want the length of the radius. So that's all they want from you, the radius. So the question is, what is the radius of the circle? But the clue they gave you is the circumference this time. So this is the clue. The circumference, C, is equal to 4 pi. You know that the formula for the circumference is 2 pi r. you want to make these equal to each other. So 2 pi r equals 4 pi. Match whatever matches on both sides and cancel it. So pi and pi cancels, leaving me with 2r is equal to 4. If I divide both sides by 2, I get r is equal to 2, which is what they asked you for, the radius. If you go back to the question, you go back and look, and you see what is the radius of the circle. You found it. R equals 2. Problem number 16 asks, what is the area of the circle? So this time the question is, what is the area of the circle? The clue is that they gave you that the circumference is 6 pi. So that means C equals 6 pi. The formula for circumference is C equals 2 pi r. Set these equal to each other. So 2 pi r equals 6 pi. The pi's cancel, leaving you with 2r equals 6. And that means we found that r is equal to 3. But if we go back to the question, they're not asking us for r. They want us to find the area of the circle. So the formula for the area of the circle is pi r squared. If we're substituting for pi, we get 3.14. And for r, we put in 3, which will become 3 squared, which is 9. And multiply that times 3.14. We end up with an area of 28.26 units squared. Because they didn't tell me what type of units, I'm going to put units. And I know it's squared because it's area. On number 17, they're asking you for the best approximation of the length of the radius. So the question is, they want you to find the radius of the circle. The clue is that they gave you the area as 16 square inches. So here is your clue. Area is equal to 16 inches squared. The formula for the area is A equals pi r squared. You're going to set these both equal to each other, which is pi r squared equals 16 inches squared. Pi is an actual number, so you can divide both sides by pi. If you do this on the calculator, I ended up with 5.09 inches squared. And so if I square rooted both sides, I ended up with a radius of 2.26 inches. Again, it's inches because this was inches squared, and the square root cuts that in half to inches. The r squared cuts the exponent in half into r. But it does not cut numbers in half, so be careful with that. This number is not cut in half. It was square rooted on the calculator. So we found the radius of the circle. Number 18 and 19 deal with this pyramid that's here and the height of the pyramid. In problem number 18, they tell you that the height is 10. The formula for the volume, they want you to find the volume. So the formula for the volume is length times width times height divided by 3. So the height they gave you is 10 centimeters. The length was 8, the width is 6, and multiply by 10 and divide by 3, you end up with 160 centimeters cubed. On number 19, they're changing the height to 15 centimeters. So this red number will change to 15 centimeters. Same idea, you multiply and divide by 3 and you get 240 centimeters cubed. On numbers 20 and 21, we're looking at this problem here with the circle and 2 secant lines. You can see that on the secant lines, we're talking about the segments, which is this x, this 4, this 2, and this 8. But for the arcs, you're looking at 80 and y, and for the angle, you're looking at 25. So the arcs and the angle go together, and the segments go together on another problem. So number 20 deals with the segments. So we're going to start with the outside, which is 4, and multiply with 4 plus x, which is the entire secant. So 4 plus x. On the other side, secant, we start off with the outside, which is 2. And we multiply with the whole thing added together. So 2 plus 8 here. So we end up finding out that 2 plus 8 is 10. And 10 times 2 becomes 20. And here on this side, if we distribute 4 times 4 is 16. And 4 times x becomes 4x. So we have 16x plus 4x equals 20. If I subtract this side to that side, the 16 to the other side, we end up with 4x equals 20 minus 16, which will be 4x equals 4. If I divide by 4 on both sides, I find out that my x is 1. On problem number 21, we're dealing with the arcs and the angle. So to set up this problem, you end up with the 80, take away the y here, divide that whole thing by 2, and then that will equal to your angle, which is 25. To get rid of the 2, which is dividing by 2, you multiply by 2. So 2 times 25 becomes 50. So I end up with 80 minus y equals 50. If I switch those, then I end up with the y from here moving to the other side as a positive, and the 50 moves to the side on the 80 as a negative. So I end up with y equals 80 take away 50. And so 80 take away 50 is 30. So that means my y is equal to 30. Number 22 deals with special right triangles, and in this case you have a 30, 60, 90 degree triangle pattern. And so if we do 30, 60, 90 and divide by the first number, which is 30, I end up with the pattern of 1, 2, and 3. The last number always gets the radical, and the 2's always get circled because those go in the hypotenuse. And the radical 3 will go next to the 30 degree angle. So if I recreate this right triangle here off to the side, I end up finding out that the hypotenuse is TU. So that ends up with 2A because of the 2 here that goes in the hypotenuse. And the radical 3 will go next to this 30 degree angle, which will be here on the bottom with an A next to it. And the 1 with an A is just an A. So that's the 60 degree, which is here. So I find out that these two blue ones here are actually equal to each other because this is the only number they gave me along the sides, and it corresponds with this side here, so I can set these two equal to each other, and that's exactly what I did here. Now I'm going to use this to help me find my other side lengths that are missing. So one of the side lengths that are missing on my problem is TU, which is actually my hypotenuse, and if I look at my hypotenuse, my TU is supposed to be 2A. So I'm going to put 2A. And I know A now. So A is 8 square root of 3. So I'm going to put 8 square root of 3 in the A spot. And I can only multiply the 2 times the 8 because the 3 is inside the square root. So 2 times 8 is 16. So the TU equals 16 square root of 3. My next missing side is SU. SU corresponds with this side here, which is A with the square root of 3. So I'm going to write that down. SU equals A square root of 3. But I know A. A comes from here. So I'm going to substitute this 8 square root of 3 in the A spot, which is what I did here. And I still have my square root of 3 here. This time I can multiply the 3 and the 3 because they're both inside the square root. So 3 times 3 is 9. So now I have a square root of 9. And the square root of 9 is a 3. Comes out as a 3, no more square root. And if I multiply that with the 8 that I had along the side, then 8 times 3 is 24. So that means my SU is 24. 23 is also a special right triangle problem. So in this case, I have a 45, which means the other angle is 45. So I have a 45, 45, 90. So if I look here, I have 45, 45, 90. Divide all of them by 45. That means my pattern is 1, 1, 2. The last one always gets the square root, and the 2's get circles. So in this case, this one's getting both, and that's going to go in my hypotenuse. So my square root of 2 goes in the hypotenuse. So once I recreate my triangle, I'm just drawing it again, and I'm recreating it, and I'm matching. So this is my hypotenuse, so this belongs in my hypotenuse with the letter A. The other two are just number 1, so they're just the letter A. So A and A. Now the only place where they gave me a number is down at the bottom, which is 5 square root of 2. And I have missing side number 1 and I have missing side number 2, which I need to find. So if I just match these up, I find out that A is actually equal to 5 square root of 2. So I now know my A. So this will help me find my missing sides. So missing side number 1 is just A. So missing side number 1 is equal to A. And I know A. A is 5 square root of 2. So that would mean that missing side number 1 is the same as A, which is 5 square root of 2. So I found missing side number 1. It's just 5 square root of 2. Missing side number 2 is a little bit more complicated because missing side number 2 is my hypotenuse. So That one is not A. That one is A with the square root of 2. So missing side number 2 is an A with the square root of 2. And I know A. A is 5 square root of 2. So I'm going to put that in the A spot. And I have a 5 square root of 2 here. So these should go next to each other. This is A and this is square root of 2. This time I can multiply the 2's together because they're both inside of a square root. So 2 times 2 becomes the square root of 4. The square root of 4 is 2. And 2 times the 5, which I have here. So square root of 2, square root of 4 becomes 2. And 2 times 5, right here, 2 times 5 becomes 10. So that means my missing side here is 10. This missing side is 5 square root of 2, and this missing side is 10. That was page 3. Page 4 of your review starts off with another special right triangle problem, but this has both type of special right triangles. So I started off here with the one that I have a measurement on, and I started with the letter A. But as you can see, some of them overlap, so I use the letter B on this side. You really could use whatever letters you want. I just use A and B in this case, okay? So if I have a 30, 60, 90, I know this is 60. That means this one's my 30, and that's my 90. That would make this being my hypotenuse. So from earlier where I showed you the patterns, it's a 1, 2, 3 pattern. So the 1s go with the 60, which is just A. The 2 goes with the hypotenuse, which is 2A. And the 3, which is the square root of 3, goes with the 30-degree angle, which I'm not seeing here, but I know it's a 30 because 30 and 60 is 90. And 90 and 90 is 180. So I know this is a 30, and this belongs with the 30 because of the 3. And it has a square root of 3. So I set up my pattern for my first triangle. My second pattern is a 45, 45, 90. So you can see from the previous problem again that this is a pattern of 1, 1, 2. So if you can see here, this is a 1 because it's a B, 1B. And this is 1B also. But the 2 goes in my hypotenuse. And it's not a 2, it's a square root of 2 with the B also. So now I have my pattern set up. I can get started with my problem. So you can see here that on my first triangle here, they gave me a number which is 22 square root of 3. So I'm going to set this equal to my 2a so that I can find a. So if I set 2a equal to 22 square root of 3, then I'm going to divide both sides by 2, and my 22 will become an 11, and the 2's here will cancel. The square root of 3 I'm not going to divide because the 2 is not in the square root and the 3 is. So I only divide the 22 divided by 2. So I found a. I'm going to use a to try and find x. So as you can see, if I look at x, x is equal to a. Well, x is equal to a, and I already found a, so a is 11 square root of 3. So that means x is 11 square root of 3. So that one was easy. Now let's go over to y, where if I look at y, that means I need to find b. So I won't be able to do this problem if I don't know b, because y is equal to b square root of 2. So I'm going to need to come back to here where I know a. So I know that b is equal to a square root of 3. So I'm going to set those two up equal to each other. So b equals a square root of 3. And I know that a is 11 square root of 3. So I'm going to substitute a, 11 square root of 3, and my square root of 3. So don't get confused. Just because you said square root of 3 here does not mean this square root of 3. Remember, there's one square root of 3 coming from the a, and there's another square root of 3 from my equation. So there's 2 square roots of 3. That makes that square root of 9. So the square root of 9 becomes 3. And 3 times 11 becomes 33. So now I found b. That's very helpful for me to have found b, because I know that y is equal to b square root of 2. So if I set this up, y is equal to b square root of 2, And I now know that B is 33. All I need to put is 3 in the spot of the B. And now I have 33 times the square root of 2. I cannot multiply them together because the 33 is not in the square root and the 2 is in a square root. So my answer for y is just simply 33 square root of 2. On number 25, we need to find the value of pi in radians. So that means you need to have pi in your answer. So in the circle below, they want us to round to the nearest hundreds. So to find the arc length, which is 8.5 here in this case, the arc length of a circle is equal to the measurement of the arc times pi, the angle, right? This is a degree, the measurement, okay? Times pi, and then times r, which is the radius, and then divide everything by 180. So there's certain things here that I actually already know. So I know the arc length, which is S, which is 8.5 kilometers. So I put that in the S spot. I don't know M, but I know when I do find M, it's going to be the same as theta. And pi, I'm not gonna substitute for pi because I want pi in my answer because they told me I want radians. And I know the radius is 20 kilometers, so I'm going to leave 20 kilometers. And I'm going to divide all of that by 180 like the formula says. Okay, so now I'm going to move my numbers around. So I'm going to leave the 8.5 kilometers here on this side. And I'm going to multiply to get rid of the division by 180. So that means it's going to go to the top with the 8.5. So I'm going to multiply next to the 8.5. And there it is, multiplied together. Now, the data is being multiplied by pi and by 20 kilometers. So in order to get rid of them, I'm going to need to divide by pi and by 20 kilometers, which is what I did here. I'm dividing by 20 kilometers and by pi. Now, after working all of these numbers out, but not the pi, I end up with 76.5 with the pi at the bottom. So I'm going to say that that's data for now. And I'm going to leave it like that since they asked me for radians. Number 26. On number 26, they want you to solve for x. So you see here that you have a measurement of 96 as a chord. But I see here that I have a right angle. So this means that I have a perpendicular bisector. That means this 96 can actually be divided in two pieces, giving me each piece being 48. So this little green triangle that I created here, when I move it off to the side, I know that from here to here is half of 96, which is 48. I also know that this little piece of the radius is 14, so I'm going to write that down. And the only other piece that is not given to you is this, because you have to use your imagination. If I'm going from the center to the circle and they tell me it's x, I could go from the center to the circle a lot of times, and each time it's x. So I could have done my triangle this way, and that would have been x. I could have done my triangle this way, and that would have been x. I could do this, and that's x. So I can make a lot of different slits, and it's x each time because that's a radius. That's what a radius is. Now, I chose only this one because I wanted to complete this triangle. But like I said, I could have gone this way and I would have made a triangle over here. Would have been the same triangle, same measurements. So this x here is that x. Now I have a right triangle, which I'm going to use the Pythagorean theorem on. So the hypotenuse squared is equal to 48 squared plus 14 squared. And all of this becomes 2,500. So if I take the square root of both sides, I end up with x is equal to 50. So, and I'm going to show you the square root here on both sides. So, square root, and so that you can see what that looks like. Here it is, square root and square root. So when I take the square root of x squared, there's two x's there, x times x, only take out 1. And this becomes 25 times 100. The square root of 25 is 5. So if you want to see that, the square root of 25. So this is the same thing as the square root of 25 times 100, and the square root of 25 is 5, and the square root of 100 is 10, and 5 times 10 is 50. So hopefully this helps. This concludes your review. I hope that you're able to study and that this review is helpful to you. And I hope you all get an A on your next test. That will make all of us very happy. So good luck.